How many of you have a job?
Oh, I need a job.
Three of us have jobs. Seriously?
Yes.
I don't care if it's part-time or full-time. Okay. Do you pay taxes?
Yes.
No, because it's under the table, right? A lot of you went cash. Yeah, fortunately. Taxes are an excellent example. The tax brackets are an excellent example of a piecewise function. Okay? And I don't know if this is right anymore. I'm going to guess that it's not. Okay. This is what's in your book. So if you have a income of $0 to $23,500, your tax liability out of your paycheck should be about 15%. This is old, like it's 15 years old. So, and then it goes up from there. So from 23,501 to 61,400. We'll do this in dollars, I guess. We're looking at 28%. Yeah, these are definitely not the current rates. I can tell you that right now.
What does the first number say?
23,500. This is 23,501. And then we're going to write 61,401 to 128,1.
So this is how much you make, that's how much you pay in taxes?
31%. Yeah, so your employer, let's say you make $100,000 a year. Every paycheck would have 31% of it taken out and sent in taxes.
What's today's rates?
They're lower.
That's
Yeah, much lower. Thankfully,
That's good.
there are two methods of thinking on taxes. One is the government can just take the money up front, and you have what you have to spend, which is kind of what this is, versus lowering taxes, letting you spend the money, and the government gets the money from you spending, right? Because there are more jobs. There are just two modes of thinking. One is more government heavy, one is less government. And then, let's see, we had 128,101 to 278,450. That was 36%. And then anything 278,450 plus 39.6. Okay, that is a piecewise function, right? In reality, you may have those taken out of your paycheck, okay? But people in this tax bracket are not paying any taxes because they get it all back. That's just the reality of it at the end, okay? If we graph this, we'll do the percents over here and the income here. Labels, units, right? 10, 40, and 50s. We'll extend. Okay, so let's get that written down.
What did the last one do?
last one. Yeah, you could be a little more, I could be a little more accurate there. Lots of ways to write that. If that, how I wrote it, that's probably more accurate. Okay.
So would you graph every single dollar value?
Yes, you do actually, but it's really easy. So no, you don't have to graph 23,500 points. You just put a line. So the 15% from 0 to 23,000. So we're going to be here, just like that. See, that line tells me at 15%, and then this value would obviously be this 23.5.
So it looks like those things on this?
Yeah, it's exactly what this is. It's just this is what's called a step function. Looks like staircase. Instead of, there's no angles, no slopes. Okay. Okay, from 23,501 to 61.4. Maybe somewhere in here. What's that? 28%. Whoa. Get her done, Bill Clinton. Right. So 28% for this time period, or this income level. Okay. Same thing here. We got 31% from 61 to 128. And I'm approximating at this point because our scale is so broad. Right. 128, 278 at 36%. So it's called a step function just because it looks like kind of steps, but there's just kind of is an example of something that you might have to deal with someday because you do have to pay taxes.
So we have to like draw this out?
Unless you're a boat. Okay. You have to draw what out?
Do we end up paying taxes? We have to do it?
No. All you have to do is say my income was, this is what should be pulled out. It's a check for you on your employer. Make sure they're taking out the correct amount. It's a little more complex than this, but we try to keep it simple. Depends on how many kids you have and if you're married, and there's all sorts of stuff that goes into it. But just a simple example. There are tax brackets. Yes?
So when you hear a person's doing their taxes, they're just trying to see if they owe the government any money or if the government owes them.
Right. If you overpaid, you get money back. If you underpaid, at that point, you get to be a lot more specific. Like your paycheck only takes into account if you're married, if you have kids, and any other voluntary deductions, right? When you do your taxes, you're talking about deducting charitable contributions and mortgage insurance and all sorts of other stuff. Yep.
So you can choose not to do it?
Choose not to do what?
Like find out how much you owe them or...
At your age, you can choose not to. Well, at my age, I could choose not to, but it'd be really bad for me because then I'd probably be in prison.
Oh.
So choosing...
If they owe you money?
They probably wouldn't complain about that, to be honest with you. If you owe them money, they are pretty
So what do you
strict
just
about
find
it.
out if you owe them and send it to them?
Yep. Write a check. It's been a couple years where I've written $20,000 checks to the government.
Oh.
So we own businesses at that point. We're making money off businesses. Okay, so economics aside, let's move on. So good example. Let's just look at a couple like pure mathematical examples, right? Then we'll move on to letting you work on something. You've seen Have you seen that function before?
No.
Oh, yeah, that's the first question.
Absolute value?
Oh, yeah.
Yeah.
I thought that was 1x.
I thought it was just 1 times
You're
1.
stupid. I'm learning.
No. Brackets, or bars, I should say, brackets are different. Absolute value is actually a piecewise function.
So for like question 1 on the homework, it says put that into piecewise function, you don't have to do anything.
You do have to, well, what we're asking you to do is write it like this.
And that's what you put your.
Do you know what the shape of the absolute value of x is, the graph? Anybody? Okay. Yeah, that's exactly what it is. Again, a go-to, if you're graphing, you can always do a table. All right? So I always start with those x values. This makes it easy. So if I plug in -1, what's my output? 1, 0, and 1, right? Okay. So I have these points. Where is it going to go from there?
Straight.
Yeah, it's just straight lines. Looks like a V, right? Don't worry, you'll get trained. When I say what does absolute value look like, half the class usually does this by the end of the year. There you go. Then I feel cool. All right. So notice that the slope changes here, correct?
Yeah.
So what is the slope of this line? 1, and what's the y-intercept?
0.
Sorry, that should be a positive 1. I'm getting ahead of myself. So 1x plus 0, right? The question is, what x values is that good for? Okay, this line is different, right? So we are just going from 0 and bigger. So you have to put that here. Okay.
So what is the other
So
one?
this only works for x greater than 0. But we can put equals there if we want. Right? So because it's only this piece of the function.
Why not the other?
Well, we're going to do the other piece.
Isn't that like y equals negative x if x is less than 1?
Right? The slope's the -1, correct, of this line? Slope -1, and it's everything below 0. Right? This is the piecewise representation of absolute value. There, homework question answer, right? We usually do not write this out. If this is usually not written out, we just write this and we know what it looks like. Okay. Your book has an example that shifts this around a little bit, up and down, left and right.
Isn't that like
Okay.
+3 or something like that?
Yeah. Just do a table, determine where it's moved. Okay. I will teach you how to move every single function that you could ever see with one method, basically. It's called families of functions later in the year. So there, any questions? Are we okay with this? Anybody confused about this part here? That's where we get most of the confusion, is on the,
I probably will tomorrow.
which is fine. When you try to work on it your own, it's like, what the heck, I thought I understood it. Okay. Let's try another one.
And then there'll be some problem, and then
Let's try this. This one has 3 pieces.
Is that x to this?
That is x less than or equal to -2. You can do tables if you want to. I'm not going to push you away from that, but these are just lines. Okay, this line is y equals 1. Okay, that's just the line at y equals 1, right? The question is, what are my boundaries? Okay. So -2, and it's an x value, is right here, correct?
So it's like,
Everything small.
so it's like a 1 segment from -2 to
Yeah, so we're at y equals 1 from -2, less than -2, right? Less than to the left. So our wall is at -2. -2. See, -2 on both of those. And it's y equals 1 to the left of that. Start. What's the next dividing line? 3, right? So at x equals 3, that's where my next division is. So one piece is going to go in here, and one's going to go out here.
So
Yeah, this one right here goes in between, and the other one, 2x, goes to the right. So I graph y equals x plus 2. What's the y-intercept? 2. And the slope?
-2.
1. There's my line. Why am I going to put a hollow dot here and a solid dot here? Yeah. So you have your less than or equal to the solid dot. That's solid. Right? And you have your not equal is open. Okay. Just keep that in mind there. Yeah. Your last, what's the equation of this? Y equals 2x. X is greater than 3, so there are a couple ways to approach these. Some people like to just graph the line and erase. Right? So if I graph y equals 2x, here's my y-intercept, and then here's my line, right? And then I can go back and erase the purple dots in there, right? Because we don't want it in here, just to the right. Some people don't mind just plug in 3. What's this point going to be? You plug in 3, 6. The 3, 6 is the point, and then go do your slope from there. You can do that as well. I find that one easier, so you don't have to worry about erasing. Okay. So just different pieces. If you want to graph each one of these, and then erase what's not supposed to be there, as long as you're working in pencil or erasable pen, right? Or you can do it like we did it here, just put the pieces on as is. Okay. Are you okay with that? Does that clear anything up that we had questions on? We spent 3 days on piecewise functions because it is kind of a big deal for a lot of units here in calculus. Okay. I mean, not really a big deal, but it comes up often, so. Most of the time, you're gonna get graphs like we've worked on in the packet. All right, I just finished. Oh, shut up. So we're gonna have problems this year, you and me? Good. Oh, this is still last week. You do have your first test is Friday. Oops, I just said it, didn't I? Nothing else in the world now matters. So today, piecewise functions. Tomorrow we do linear inequalities. Thursday's review, Friday test. Okay. We have taken our time on this chapter, so hopefully you got it. But if you don't, please come get help, because I'm here. That's what I'm here for. Yes, sir.
Are we gonna get some sort of blue sheet or like?
You get a half blue sheet this year.
I hope he does it already, but that's because he was going to work.
You get one of these. Write whatever you want on it for your test. Yeah, there's plenty of room.
And so this, so like what if there's a point, there can't be a point there, right?
No, because this function is not.
So this function that means that there's x value in
Like
between
it gets
there.
second place because I missed the point.
Yeah, so
It'd be on this line.
you plug -2 in, you get 0. Right? Should have been 0.
Oh, no. Just say that.
That's right. Then if you plug 3 in, then you get 5. So mine might be 2.
Okay.
Yep.